Welcome, colleagues from different regions in the world. It's really a pleasure for me to welcome all of you to this webinar where we will be launching the WHO protocol for a One Health model for surveillance, the well-known TriCycle model that will be presented during this webinar. I would particularly warmly welcome the colleagues that have committed, supported the development and implementation of this protocol. In special, I would like to warmly welcome colleagues from the Food and Agriculture Organization of the United Nations, the colleagues from the World Organization for Animal Health, and many scientific partners that have collaborated for the development and implementation of this protocol. As you may all know, that right now, many countries are trying to gather information to inform actions to address antimicrobial resistance. And they are building capacity to establish surveillance systems, gathering information from many sectors that are related to the emergence and spread of antimicrobial resistance. And AMR does not only affect humans, but also animals, plants, and the entire environment. It is a truly One Health issue and requires multi-sectoral collaboration as a key approach to reach the goals in the containment of antimicrobial resistance. On the other hand, we all know that surveillance, any type of surveillance, does require resources, and resources are limited. Countries do need to find the best approach that proves to be feasible and at the same time respond to the needs for strategic information. So today, with this protocol, we will present a model that offers an approach that is multi-sectoral, that does take into consideration the One Health aspects of antimicrobial resistance and provides then a surveillance approach in a multi-sectoral and integrated manner. So without further ado, I would like now to give the floor to my colleague, Dr. Jorge Mateo, for presenting the agenda for today. Thank you, Jorge.
Thank you, Carmen. Good morning, good afternoon, and good evening. Thank you for joining. Let me share with you the agenda for today. So after this opening remarks, we will have the tripartite presentation. We have the colleagues from the Food and Agriculture Organization of the United Nations. We have also, from FAO, we have Alejandro Dorado, who is going to present the FAO's work on AMR and AMU, antimicrobial use of antimicrobial monitoring and surveillance. We have Jorge Pinto Ferreira from the World Organization for Animal Health, OAI. After that, the background about the TriCycle protocol will be presented by Jorge Mateo. And then we are going to elaborate a bit more on the working packages, how was defined, how was selected, the different working packages that are included in this TriCycle protocol. We will have Olivier Vandenberg, who is going to present the working package 1 on the human health. We have Jaap Wagenaar, who is going to present the working package 2 on the food chain. Heike Smith presenting the working package 3 on environment. And Rene Henriksen, who is going to present the working package 4 about the molecular analysis of the isolates of the 3 main packages that will be presented previously. After that, we are going to have country experience. So we have Dr. Afrinish Amir from the National Institute of Health in Pakistan. They are going to share with us this experience, how was the proposal, the implementation, the approval by the government to implement this Tricycle protocol. After that, we will have the partnered perspective from Fleming Fund, that was the funder and the donor for this protocol development. From Fleming Fund, we have Jessica Wallace, who is the deputy head of this Fleming Fund. After that, we will have the perspective for the ESBL Tricycle protocol by Antoine Andremont, one of the main minds behind this idea initiative of the Tricycle protocol. Then we will have some time to discuss the question and answers. And after that, we will have closing remarks. I would like also to mention that we have additional panelists from FAO. We have Jeffrey Lejeune. From OIE, we have Dr. Elizabeth Erlacher. Thank you for joining. And also the expert, one of the experts of the Tricycle protocol, Dr. Morgan Scott from Texas A&M University. Thank you for joining. And the last is about the information for participants. We are recording this webinar, so we will share the link to all of you, and also to share with other colleagues that maybe could not join to this at this moment. There's you can find the Q&A section that you can ask, and the different colleagues and panelists that are here can answer the different questions. And the protocol will be available this week. We are going to share the link as well. So this is the information. So we can start with the presentation of the overview of the activities on AMR by Carmen Pessoa. Carmen, over to you.
Thank you very much, Jorge. So if you could please put my slides. So colleagues, in my very short presentation, I would like to share with you an overview of the status of the WHO Global Antimicrobial Resistance and Use Surveillance System. If I could have the slides, please.
Yes.
Yes, please. And the PowerPoint. Next, please. In May 2015, all WHO member states approved by unanimity the Global Action Plan on Antimicrobial Resistance that has 5 strategic objectives. And this action plan is meant to ensure for as long as possible continuity of successful treatment and prevention of infectious disease with effective and safe medicines that are quality assured, used in a responsible way, and accessible to all who need them. But this, in the same year, where in the same resolution that approved this Global Action Plan, member states also requested the WHO to develop a global antimicrobial resistance surveillance system. And I have to underline that also the WHO member states, they were very much conscious that the One Health approach should be addressed in all aspects of the Global Action Plan. So the next, please. Following this request, in the end of 2015, WHO launched the Global Antimicrobial Resistance and Use Surveillance System, as it is known by GLASS, the acronym. And this is the first global system to incorporate official national data from surveillance of both antimicrobial resistance and antimicrobial use. It provides standardized approach to the collection, analysis, and sharing of data. It gathers not only microbiological data, but also epidemiological and clinical data. And from the start, we were conscious that we would need to also have a One Health model for AMR surveillance included in the system. Next, please. While we're conscious that we do need information, not only from human health, but also from the food chain, from the environment, regarding antimicrobial resistance to then inform actions. We did start as a component that focused on human antibacterial resistance. And GLASS does really look at events, antimicrobial resistance related events that may impact on human health. May it be events in the environment, in the food chain, but with direct impact on human health. The starting point was the monitoring of bacterial resistance in humans. Next, please. But nowadays, well, in these 5 years of GLASS existence, we started with the first component under routine data surveillance on antimicrobial resistance surveillance, the GLASS AMR. But since then, we have evolved, and the current GLASS environment since last year includes different components. I highlight in this slide in dark blue the components that are already active in the new GLASS environment. Some other components in a clear blue are in the initial phase of their implementation. But I would like to call your attention particularly for the One Health AMR surveillance, the GLASS One Health approach in green box. That is exactly what we are launching today. With the launch that we are doing today, we will be incorporating this component also in the GLASS system. Next, please. As of today, 106, the slide is already out of date because yesterday another country just enrolled in GLASS. So today we have 106 countries and territories enrolled in GLASS. And what you can see in purple reflects the enrollment for the first component that was on antimicrobial resistance surveillance. But now we have also the antimicrobial consumption component, and many countries are already enrolled in both. And more components will be bringing more colors to these slides as the countries are also embracing new components. Next, please. So just to conclude this very short presentation, I would like to highlight that GLASS is continuously evolving and will continue to evolve to meet the needs to inform national, regional, and global strategies. And although GLASS does focus on human health aspects, the incorporation of the One Health component is key to improve the understanding of the links across the sectors. And last but not least, what is fundamental for the inclusion of components, especially the component on One Health, is the collaboration with colleagues from the animal health and the environmental sectors as key to enhance the surveillance approach that could better inform strategies to tackle AMR. And with that, next, we will leave you also with some links where you can find more information regarding the WHO surveillance systems addressing antimicrobial resistance, and thank you for your attention.
Thank you, Carmen. So I will give the floor now to Alejandro Dorado Garcia from FAO to present the slides. Please, Alejandro.
Thank you very much, Jorge. And thank you very much for this opportunity, colleagues in WHO, to present on the FAO work on antimicrobial resistance and use monitoring and surveillance. So I will show my slides. Wait, just a second. Okay. Oh, I think you can see also. You can
yes, we can see. Yes, we can see it, Alejandro.
Okay, are you seeing the notes, or are you seeing the progress?
We are seeing the slides, the complete slides. Thank you.
Okay, perfect. So you're not seeing the notes, I understand. Okay. So thank you very much. So I will present on the FAO work on antimicrobial resistance and antimicrobial use monitoring and surveillance. Just one second. So the work of FAO on AMR is multisectoral by nature, and FAO is providing support to members in different areas, including terrestrial and aquatic animal health, food and feed safety, genetic resources, crop production, and natural resource management, with cross-cutting support across all sectors on behavior change and strengthening of regulatory frameworks. Under the new proposed FAO action plan on antimicrobial resistance for the next 5 years, strengthening surveillance and research keeps being one of the key objectives. And I will just provide a quick overview of the work that FAO is doing on surveillance, providing some highlights on the work on available tools for capacity building, the deployment of field interventions, and the provision of access to technical resources and networks. So for the first one, for FAO tools, FAO has strongly focused so far on building country capacities on the ground to generate, collect, and analyze AMR data. Now, for this purpose, the FAO developed the assessment tool for laboratories and antimicrobial resistance surveillance system, the FAO Atlas. And Atlas missions have been deployed, the tool in more than 28 countries and 100 laboratories around the world so far. Also building a global community of assessors that is helping to harmonize global surveillance efforts. And Atlas is basically composed of 2 modules, one for assessment of surveillance and the other one for assessment of laboratories. And the tool is using standardized questionnaires for mapping the capacities of countries across relevant areas for surveillance. And after the analysis of responses, targets are defined for improvement of laboratories and surveillance systems, and the progress is measured through a progressive improvement pathway specifically designed for this tool. Now I'm moving to field interventions. And here I would like to illustrate with an example the work that FAO is doing for monitoring and surveillance through the deployment of field interventions. In these pictures, you can see the implementation of a study in which around 1,000 farmers were surveyed on their knowledge, attitudes, and practices to understand antimicrobial use contexts. And the results of these surveys have been used to tailor interventions and to develop farmer field schools that are now being a platform for community-based monitoring of antimicrobial use, but also for monitoring of antimicrobial resistance through the collection of fecal samples and antimicrobial susceptibility testing in the participating farms. Now moving to the highlights on technical networks and resources. And here I would like to mention that recently in 2019, FAO initiated the establishment of a technical collaborative network of FAO reference centers for AMR. And for now, the network includes the 7 institutions listed in this slide that are in Denmark, in Germany, Thailand, the UK, the United States, France, and Mexico. Additionally, FAO also facilitates the creation of technical advisory groups for antimicrobial resistance and antimicrobial use surveillance in different subregions as a forum for sharing experiences and coordinate efforts in harmonization of activities and surveillance approaches. FAO is also producing a wide variety of technical publications and guidelines, also related to the surveillance, and all of them are available in the FAO website. For instance, one of the ones I would like to bring attention to is the one published by the Regional Office for Asia and the Pacific that has published the guidelines for monitoring and surveillance of antimicrobial resistance in healthy animals and food. And the additional guidelines are under development to cover surveillance in terrestrial and aquatic animals, pathogens, for animal health, of course, and monitoring of antimicrobial use at the farm level. This guideline for antimicrobial use at the farm level is produced with colleagues in WHO. And finally, there is another guideline or technical document in production for the monitoring of antimicrobial resistance and residues in production environments. So we all know, and that's why we are all today here, that the integrated surveillance across all sectors following a One Health approach is essential for tackling antimicrobial resistance. And the approval of country and global projects under the Tripartite Multi-Partner Trust Fund is helping to set in motion more integrated surveillance activities. So one of the global projects that will raise the profile of the environmental aspects of AMR, and for example, another global NPTF project is going to focus on the development and establishment of the tripartite integrated system for surveillance of antimicrobial resistance and antimicrobial use, which is called TISA. And this system will integrate global data coming from the three organizations. Additionally, FAO is also working on the establishment of an international AMR-AMU monitoring data platform to support members in the collection, analysis, reporting of antimicrobial resistance and use data in food and agriculture. And this system will also be linking to TISA. And finally, I will also like to finish with the joint WHO-FAO work under Codex. And the Codex Alimentarius has developed a range of international standards and guidelines related to antimicrobial resistance. Some of these, such as the guidelines for risk analysis of foodborne AMR and the code of practice to minimize and contain antimicrobial resistance, directly support national efforts to minimize and contain foodborne AMR, while others, such as the general principles of food hygiene, indirectly support these efforts. Work is also currently underway, and this is especially relevant for this webinar, on new guidelines to support the integrated monitoring and surveillance of foodborne AMR, which will complete the suite of Codex texts to support country efforts to address antimicrobial resistance. And I think, yeah, this is all from my side. Thank you very much.
Thank you very much, Alejandro, for sharing this. I will give the floor now to Jorge Pinto Ferreira from OIE. Jorge, please, over to you.
Thank you very much, Jorge. You can all hear me and see my screen?
Yes, Jorge, we can see and hear you very well.
Perfect, thank you. Thank you for the opportunity to present in this meeting. So my name is Jorge Pinto Ferreira, and I'm the Deputy Head of the Antimicrobial Resistance and Veterinary Products Department at the OIE. And it's a pleasure to present here our activities regarding the use of antimicrobials, considering that in the work package 8 of the Tricycle Protocol, it is mentioned the link to other data collection systems, and it is recommended that countries that are collecting use data on animals should follow the OIE methodology for that. So it's under this background that I'll be presenting our activities under this subject. I guess most of you know what the OIE means, is the historical traditional abbreviation for the World Organization for Animal Health. And just a quick note that we are based in Paris, the headquarters is in Paris, with 182 members, a few regional and sub-regional representations, and that we will focus our work on animal health, welfare, and veterinary public health, and that the standards are set by the OIE are recognized by the World Trade Organization. So just a quick, in a nutshell, what the organization is about. We do develop standards and guidelines, and just a quick note on a quite important guideline regarding the use of antimicrobials. The OIE has its own list of antimicrobial agents of veterinary importance. The link to access it is in these slides, and this presentation can surely be shared afterwards. And in this list, there's a specific set of recommendations regarding the use of specific classes, namely the last generations of cephalosporins, fluoroquinolones, or for example, a molecule like colistin. So this is just to highlight the list itself that we see as a guideline, and the recommendation sections of this list. Moving on to the standards. So the standards are, for the OIE terminology, is what we have in the terrestrial animal health code and the aquatic animal health code and the manuals. And here you see highlighted or underlined the chapters of these codes that refer to the monitoring of the quantities and usage patterns of the specific animals, either terrestrial or aquatic. And all of these documents and chapters are available online publicly, so you can access them easily. So the two next slides just highlight or go into further detail of what I said, the standards regarding terrestrial animals and aquatic animals. And so our methodology to collect data on antimicrobial use of agents intended for use in animals is based on these standards, is based on these chapters of both codes for terrestrial and aquatic animals. If you want to get the whole details of the methodology, I would suggest that you have a look at this publication. This is a peer-reviewed scientific publication that we published a little over a year ago, so in September 2019. And there you have all in detail, the methodology that you use to collect both the numerator and the denominator, meaning the quantity of the molecule itself or the class itself, and then the animal biomass regarding the denominator. So this is also a public, free available publication. And if you want to see the whole details of the methodology, they are described in this publication. Regarding the reporting options, a quick note on this, that the countries or the members have different options to report the use that they do. So the baseline information is just qualitative data, and then there's 3 reporting options of quantitative data that go into additional granularity. So they provide more information to us regarding the use that they're using of agents. So you see on the right side of the slide what each reporting option means of the quantitative ones. And this is to have in mind that we are a global organization. We collect data at the global level, and that we know that members are at different level of development of their systems for surveillance or monitoring. And so this is a way to adjust the difference that we know exists across the world. A note on this, if you want to find some of these documents, it's just to facilitate, to expedite where to find it in the OIE website. So this slide will be shared, and here you can find the questionnaire they sent to the members, the guidance, the annex, etc., and the reports published so far. So this is just to make your life easy if you want to find them in the OIE website. Regarding the reports, so we are about to publish the 5th report on antimicrobial use. So the data collection is basically a year-round, a cycle, let's call it a cycle. So we finished the 5th, and we are about to publish the report of this 5th round. And at the moment, we are finishing the 6th round of data collection to be published next year. So we published 4 already, the 5th is coming up. And in the bottom of this slide, you can see something that we are quite pleased about. We have, for the last 5 rounds, we have always an increased number of members participating, sending us data, and the granularity of the data has also been increasing. And this is the result of different things, including, for example, the trainings that we do at the regional level to facilitate, to explain better, to clarify the doubts that countries might have when it comes to reporting the use to us. And an important point is this, the interaction with the countries. We are speaking about Tricycle is also about data collection. And we have been discussing with several experts and colleagues. And at the end, there is also this validation step of the data that even if you have all these wonderful softwares and machines and databases, is usually human making sure of that. And we have 3 colleagues, Morgan, Delphi, and Medudzi, working full-time on the data collection. And they have a huge interaction with countries to make sure that the data that we receive is validated. And note, you see the bottom, the box in the bottom of this slide, highlighting that 80% of the countries changed their original submission. And this is not at all done intentionally with purpose, wrongly purpose, but it's just because there were some things that they didn't fully understand. And so after clarification, the submission is slightly edited. So this is to highlight the importance of the interaction with countries, individual countries, and the data validation. Moving on to conclude, a note on TISA, and Alejandro very well brought it up. So the TISA is this idea of the tripartite integrated surveillance system for surveillance on AMR and AMU. And this is a long wish from the tripartite organizations to have this platform. And the abbreviation is simpler than the full name, but the idea is to have a single platform where we can display the data, where at least initially visualize the data that we all are collecting. In full is a dynamic platform intended to make available or display initially in a user-friendly manner on a global and regional basis, validated and official data provided by countries to FAO, OIE, and WHO on patterns and trends in AMU and AMR in humans, animals, food, plants, and the environment, while recognizing that sectors are at different level of advancement. So this is, in a nutshell, what this platform will be about. And so we concluded in the past a feasibility study, how to make this platform, that was very useful to work out some differences that we needed. And now the multi-partner trust fund will allow the further development of this. It's one of the, like Alejandro said, it's one of the 4 global programs funded. And in the next 2 years, we need to further get into the details. How can we display initially and hopefully in the future integrate this data collected, all the data collected by the three organizations. So this is an exciting work that we will have in front of us for the next 2 years. And the last slide about the future of the OIE data collection, we are building a database. So this means that until now, it was useful to collect the data via an Excel template and an Excel attachment. And now that we have this database being built as we speak, so it will hopefully, setting deadlines is always tricky, but it's being developed as we speak, so it will be available in the near medium term. And the database will has these advantages. It looks into further granularity of the data, thinking about species level, animal species level, and field level data, and improving the country's ownership of their AMU and data accuracy. So this is something that we are highly committed at the moment in the development of this database. And that's it for me. I'm happy to take further questions at the end. Thank you, Jorge.
Thank you very much, Jorge, for this very nice presentation. So now it is my privilege and honor to invite my colleague, Jorge Mateo, to present the Tricycle Protocol. And I'd like to highlight that Jorge Mateo has been a major champion here in WHO in the development and implementation, following the implementation in several countries. So it's my pleasure to give the floor to you, Jorge, to present the protocol. Thank you.
Thank you very much, Carmen. So I will start this presentation. And of course, also the experts and colleagues that have supported this implementation will also share, because they have led the development of this Tricycle protocol. Some of the background that I would like to share about why this idea of the Tricycle protocol is, Carmen mentioned the resolution where the Global Action Plan was adopted by the countries, by the member states. And this resolution is also highlighted the need for this coherent and comprehensive and integrated approach at global, regional, and national level in One Health. It also is beyond, and is involving different actors and sectors. So it's a bit complex if we are talking about this. And I know that many countries are doing many efforts to establish and implement the national action plans, including the One Health approach. There's also the Interagency Coordinating Group, the report to the Secretary General of the United Nations in 2019, where is also one of the recommendations is strengthening integrated monitoring and surveillance systems. And last year, in December 2020, was established the Global Leader Group on Antimicrobial Resistance, and they have an advocacy role for tripartite work, and also the recommendation that I mentioned from the Interagency Coordinating Group. So after the development of the Global Action Plan, you can see that the tripartite organization have worked. We are doing a lot of efforts to support in each sector, but also working together. And the manual for developing the National Action Plan was developed with this tripartite collaboration. So just to talk a bit more about the complexity of antimicrobial resistance, we see here that there are not just different sectors, but also subsectors. And countries need to implement this surveillance system to know what is the magnitude and how related is the resistance that we are finding. And also what is the status of the use and consumption of antimicrobials. So seeing this scenario that is already complex, we have also the bacteria that we are trying to detect and see the resistant rates in the different sectors and how they are related. We have Salmonella with different serotypes, Campylobacter, Vibrio, Clostridium, and Staph aureus that can be also pathogen for human and animal, for animals, and some indicators as E. coli and Enterococcus. But for this, we need laboratory capacity and well-trained staff. That is some of the activities that the colleagues from FAO and OIE mentioned they are doing. So we need to build this capacity, and countries are doing this, but there are different stages of the different sectors. There are some advances in the human sector. Some countries are more advanced in the animal sector or in the environment, but the stage is different, and that's why it's also some of the reasons why was established this tricycle protocol, the indicator that I will explain later. So both these activities should be put in place in countries to start to know what is the resistant rates of the different pathogens and compare among the different sectors. So based on the last report of this tripartite antimicrobial resistant country self-assessment, we can see that there are many countries in early stages to establish this multi-sector and One Health collaboration. And it's not just for low and middle income countries, but also for high income countries. So that's why we are seeing that the scenario, additional to be complex, is also the countries are trying to establish this multi-sectoral collaboration in countries. So the idea is to facilitate the process to establish a more comprehensive approach. WHO has launched some years ago this guidance on integrated surveillance for foodborne bacteria. And this, the last version that was launched is very specific for covering the surveillance of resistance, the surveillance of use of antimicrobials, and then the full integration, the analysis of the data of both use and resistant to know specifically how is related the use with the resistant rates that are found in the different countries. And that can also be used and useful for countries to establish the strategies to contain the antimicrobial resistance. This guidance also had the different recommendations to establish the different elements in the integrated surveillance system. Additional to this guidance, the Advisory Group on Integrated Surveillance, AGSAR, has supported many projects in countries. From 2017 to 2019, 16 projects were supported, but the approach was different. The sector the different proposal that was supported were in different sectors, were different pathogens. So when we try to compare this information, to have some data to compare with among the different countries in the projects that were implemented was difficult because, of course, the information was totally different. So that's why was another reason why the Advisory Group on Integrated Surveillance in the meeting in 2015, they brought this idea to establish a standardized protocol that was feasible and simple to implement and follow, and support also actions at national, regional, and global level. It was when the Tricycle Protocol was born. So let me explain a bit more about the principles. And again, I need to repeat that there are many efforts in countries to implement the National Action Plan. And this One Health approach is an additional effort, is multi-sectoral support that should be established in each country. So that's why the principles of this tricycle was simple, with one indicator, that is the extended spectrum beta-lactamase producing Escherichia coli, feasible, that can be easy to implement in any country with just few resources, the multi-sectoral engagement. And that is one of the things that we have seen, and I think that the colleagues from Pakistan will show more about this. The experience of the tricycle to establish this multi-sectoral collaboration has been very, very good. The three sectors have been working together. They established the core group that I will explain later. So this is another added value that this protocol is bringing to the countries to facilitate this establishment of the collaboration, multi-sectoral collaboration. As I mentioned, require few resources for laboratory because it's a simple bacteria and also simple resistant mechanism. The training to implement this protocol is also easy or feasible to implement. In data management, that most of you know this HUNE tool that is being used for a collection of data in the GLASS system that Carmen mentioned, but also there are some regions working in the animal sector using HUNET. And also the standardized approach of this tricycle protocol with a standard methodology that I will explain later. The aim of this protocol is to provide member states with a common, simplified, and integrated multi-sectoral surveillance system to detect this specific indicator, the ESBL producing E. coli, and the three different sectors. Rationale, why ESBL producing E. coli? Because there are rate variation in the rates of ESBL colonization in humans and among countries, and the prevalence trends over the time. Is variable prevalence among farms, animals, and the presence of this indicator in the environment has been seen. The interventions leading to decreased exposure to antimicrobials in animals or humans have been followed by decrease in the ESBL E. coli occurrence rates. And also, of course, the ESBL confer resistant to the critical important antimicrobials that we are trying to preserve. What we propose in the country is to establish a core group, and the support at global and regional level is there. So we established the three main packages: the human, the food chain, and the environment. With the samples, the colleagues will explain more on this. We also establish this molecular characterization because at this stage, we are just collecting isolates. And this molecular analysis is very important because it can be the first step to find some different genes circulating in the different sectors or common genes, of course. So this is something that depends on the capacity of the country. But additional to this, if the country doesn't have this capacity, the support from collaborating center has been provided. We also suggest the country to establish this group, the epidemiology, to support the design and analysis of the tricycle in the next steps of the tricycle. The linkages with the GLASS that Carmen mentioned, and also what Jorge Pinto Ferreira mentioned about the use of antimicrobials in the animal sector is linked with this, because if the country is collecting this data, and with this data collected with the tricycle, in additional with the data that WHO is also collecting in antimicrobial consumption in the human sector, we are collecting the data that we need to integrate and to analyze and expand this system that we are trying to support in member states. As I mentioned, we provide the support to countries and suggest the countries to establish the core group. The core group is 5 people. For the implementation, the first stage of the implementation, 2 people, that is epidemiologist, 1 epidemiologist and 1 public health specialist to support the coordination, management, but also the analysis and design. And then the other 3 colleagues working in each of the sectors. Mainly we are suggesting microbiologists leading these 3 sectors to implement the methodology in the laboratory. But the tricycle is also bringing more information. When the core tricycle is being implemented, you can also, the country can have the added value to link with the other United Nations proposed surveillance system in the field of AMR, but also opportunities to add satellite surveillance and research projects, protocols around this tricycle to give the shape, to also know more the relationship, because at the first stage, the tricycle can be easy for some countries, but it's the base. It's the first piece to build the national integrated surveillance system. So some of these satellite opportunities that we mentioned in the protocol is, for example, residues of antimicrobials, advanced epidemiological studies, for example, the detection of carbapenem producing enterobacteriaceae, to add also the analysis for other foodborne pathogens, to add other approaches, and of course, as I mentioned, the whole genome sequencing to be implemented in the country. For the laboratory, for this protocol, we standardize a culture media, and this standardization was published. You can find the paper. We can share the link, of course. For the human and food chain, we established the McConkey plus cefotaxime with this concentration, 4 micrograms per milliliter. And for the environment, because the McConkey is not easy to select and see the specific colonies of E. coli, this TBX media plus cefotaxime was established in this specific working package. The ESBL confirmation is following the standard established, UCAS standard and the CLSI standard that most of you know, and is highly recommended, of course, to perform the complete antibiogram with the different antimicrobials that has been established at national level. But this depends on the capacity of the country. So you can see that the protocol is basic. Thank you very much.
Thank you very much, Jorge, for this very comprehensive presentation of the protocol. Now it is my pleasure and honor to invite Dr. Olivier van den Berg from the School of Public Health, Université Libre de Bruxelles, in Belgium, to present the work package 1 on human health. So the floor is yours, Olivier. Thank you.
Thank you very much, Carmen. Thanks for this nice introduction and for the opportunity to present the human part of the TriCycle surveillance. I would like to take the opportunity of this webinar to warmly thank the WHO and especially Jorge Mathieu Alvarez for making One Health and antimicrobial resistance surveillance possible. This webinar is the achievement of a long journey. Next slide, please. Antimicrobial resistance represents a threat to individuals. AMR leads to a longer duration of illness, a longer treatment, higher mortality, and the treatment with expensive drugs. Next slide, please. Beyond this general consideration, we must remember that the chance of survival of a patient with sepsis decreases by 8% per hour of inadequate antibiotic treatment. This is why the knowledge of antimicrobial resistance and the improvement of clinical laboratory capacities are essentials. But by its integrated approach, the TriCycle program contributes to achieve these goals. Next slide, please. What about sample collection in humans? In order to better estimate the prevalence of ESBL E. coli, 2 key populations will be considered. We will collect data from the hospital level by assessing the proportion of ESBL E. coli strains isolated from positive blood culture. At the community level, we will assess the prevalence of fecal ESBL E. coli colonization in healthy pregnant women approaching or at delivery. Next slide, please. The detection of ESBL E. coli from patients with bloodstream infection will be done according to the routine method in use in the laboratory for bacterial identification. It's not a research project, it's a surveillance project, and we will integrate the project in the routine work of the lab. But as a part of the TriCycle surveillance, we are asking all participating laboratories to further characterize all E. coli to find out if they are ESBL producers. Next slide, please. The detection of ESBL E. coli from pregnant women will be done on a voluntary basis, and an informed consent will be obtained before sampling. In the frame of the TriCycle project, we recommend to collect a rectal swab or a stool specimen from at least the first 9 women attending the healthcare facility each month. The specimen collection could be done at delivery or at the last routine visit before the delivery. And of course, we have to get the consent before the participation in this surveillance. Next slide. On this slide, you can see the minimum set of information to be associated with each specimen collected for the work package 1. We will need to get patient ID, hospital or clinic name, date of admission, the date of sampling, the ID specific number, sex, age, the isolate number, the ESBL screening result, the isolate ID confirmation, and the AST results. I thank you for your attention, and I give now the floor to my colleague and friend, Jaap Wagenaar, who will present you the food chain part of the TriCycle program. Thank you for your attention.
Thank you, Olivier, and welcome, Jaap. Please take the floor, Dr. Jaap Wagenaar from the University of Utrecht, and also the head of one of the WHO collaborating centers supporting AMR surveyors. Jaap?
Thank you, Carmen. It's a pleasure for me to present the food chain part. So the food chain is a very diverse part, but we are focusing on what is in the next slide, on poultry as an indicator for the food chain. And why have we taken poultry? Because it's frequently consumed, what means that it is highly relevant. It's raised around the world, so in all the regions of the world, we have poultry. There are hardly religious aversions, and samples are readily available. And we heard already about integrated surveillance. The sampling can be combined with other bacteria in integrated surveillance, like Salmonella and Campylobacter. Next slide, please. And why the cecal samples at the slaughter for AMR surveillance in TriCycle? In fact, when you do sampling from the food chain, you can do that in living animals at a farm, you can do that in animals at slaughter, or you can do that with products that are at selling points for the consumer, so retail or markets. We have chosen for the animals at slaughter. And why? Because when the gut is closed, it's a good reflection of the farm. And we heard already that we are interested, in fact, in this primary production. And the logistics are much easier in a slaughterhouse than sampling at a farm if you want to sample individual animals, because otherwise you have to travel a lot, and in the slaughterhouse, the animals come to you. There are some disadvantages. There is a risk for cross-contamination. So it might end up, if you are not careful, that you are sampling the environment. And another thing that needs attention is that you have limited or no knowledge of the source. So we want to have unrelated samples. And are you sure that when you buy them at different places on the market, that they are really unrelated? So that's a point of attention. Next slide, please. So in our protocol, it's CECA from poultry at slaughter, and then the CECA has to be still closed when you transport them to the lab to prevent this cross-contamination. Then there is a level of detection, the sensitivity of the method. In fact, we have 3 levels. You can do direct plating on non-selective media. What I mean is without antimicrobials. There you have a lot of susceptible E. coli that you find, so your method is not very sensitive. You can do the direct plating with antimicrobials, so you select for the ESBLs, and you can do enrichment of these ESBLs, what means that you, when you have a few, that you really enrich the sensitivity of your method. But next slide, For this method, we have chosen for this protocol for the direct plating. And when we started, it was a kind of a risk and a lot of discussion. But after the pilot, it turns out that this level of detection is really discriminatory between countries. So you can really benchmark different countries in different production types. Next slide, please. And then where to sample? We suggest to sample the wet market in the capital or a wet market in the second largest city. Or you can do, when there is no wet market, you can do any other slaughter facility. It's important that the animals are for domestic consumption, what is usually the case when it's a small proportion that is slaughtered. And it's important that the samples, I already stressed that before, are epidemiological independent. So try to find out that with the people who are selling these animals. And then the number of samples, based on the epidemiological analysis, it's needed that you need about 240 samples over a year period, and a target of about 20 samples per month, to keep in mind that there might be a seasonal variation depending on treatment of animals during certain periods of the year. And my last remark is I cannot, as a veterinary microbiologist, stress that we describe a certain protocol, and please do not make variations on the protocol. In all small differences in the protocol can already lead to differences in the selection of your E. coli. That was my last remark, and I give over to the next presenter. Thank you.
Thank you very much, Jaap. And it's my pleasure to invite Dr. Heike Schmidt from the WHO Collaborating Center at the National Institute for Public Health and Environment. So please, Dr. Schmidt, the floor is yours. Thank you.
Thank you. It is indeed a pleasure to be present on this festive day of the publication of this protocol. I would like to introduce the method of the environment, and with respect to the transmission of ESBL producing E. coli in the aquatic environment. Sources of ESBL E. coli consist of animals, farm animals, but also wild animals. These could defecate directly, or manure could be applied to fields and then be brought to surface waters through runoff. Another very important source is human waste that can reach the aquatic environment, for example, through direct release into surface waters, but also once wastewater has been treated in wastewater treatment plants and is then emitted to rivers. And why do we regard the aquatic environment of all environmental compartments that you could think of as an especially important one? Next slide, please. Because the aquatic environment actually also can lead to human exposure through usage of surface water for drinking water production, but also usage of surface water for irrigation of produce, and also direct human contact with water. So we see two aspects. There are sources of contamination of rivers, surface waters, and rivers can act as a source of exposure. Next slide, please. The setup of the environmental testing within the Tricycle project contains both of those ideas. So we aim to sample both sources as well as the receiving environment. And for the sources, both human wastewater is going to be sampled as well as animal wastewater. And the selection of sites to be sampled for the environment consists of a river. Next slide, please. So the specific choice of locations for sampling consists of the following 4 sites, which are going to be sampled within a single city. First of all, human wastewater, depending on the services at the city. This could either be urban community wastewater, larger wastewater channels, or these could be samples from a wastewater treatment plant. Animal wastewater can consist of wastewater from a slaughterhouse, preferably a chicken slaughterhouse. And if that doesn't exist, wastewater from a wet market. And then the river is going to be sampled at 2 places. First of all, upstream the city and then downstream of the city. And the upstream sample serves to inform about the background on contamination upstream of the city. There will be other sources that have impacted the river there, so it's not a clean background, but it's a background to the city. And the downstream sample can then serve to compare the influence of the city from comparison with the upstream sample. And notably, I would like to mention 2 satellite extensions, as Jorge has already highlighted. If there's a particular interest of a given country in, for example, the contribution of hospitals to wastewater contamination, then hospital wastewater could be studied as well. And also, if there are concerns about drinking water quality, then drinking water can also be analyzed for the presence of ESBL producing E. coli. Next slide, please. With respect to the sampling frequency, these 4 locations that were just described within one city, the animal wastewater, the human wastewater, the river upstream and downstream, are going to be sampled in 2 cities per country, in the capital city, which is also the city in which the other work packages are going to sample, and also a second city, which should have a size of about 100,000 inhabitants. And the idea here is that the capital cities will vary greatly in their size and in their population density. So we would like to also sample cities that are of a comparable size across different countries, if that is possible within the sampling distance. As sampling for sure will be influenced by conditions that vary across the year, the seasons, precipitation, sampling should be stratified across the year with 8 till 12 sampling rounds, and that would lead to a total of 64 until 96 samples. What is the end point of the analysis here? This is slightly deviating from what we are using in the other work packages, so I'd like to spend one slide here. From experience in the Netherlands, we learned that if we study ESBL E. coli in raw human wastewater, we find 100% prevalence. So in each and every sample, we would find ESBL. That means if we want to compare countries with respect to their prevalence, prevalence is not an ideal sensitive marker of differences in prevalence. Therefore, instead of the mere prevalence, presence or absence of ESBL in a water sample, we suggest to investigate the concentrations of ESBL E. coli, thus to quantify ESBL E. coli in the samples. The second point is that the concentrations of ESBL E. coli also might vary depending on other factors, most importantly, rainfall, precipitation, and dilution in the river. Therefore, we also seek for an outcome parameter that is less influenced by precipitation. This is the percentage of ESBL E. coli among E. coli. That means that we also have to derive the concentrations not only of ESBL E. coli, but also of non-resistant E. coli, which is very similar to other measures of water quality, so very well known to many countries. And from these 2 parameters, we can derive the percentage of ESBL in E. coli. And as these are slightly different outcomes, there's also an example slide with the hypothetical outcome in the next slide. On the left-hand graph, you can see what results could look like from a country with respect to ESBL E. coli concentrations, from upstream samples via human waste and animal waste to downstream samples. And here the concentrations of ESBL E. coli in human waste are highest, are about 1 million times higher than in the upstream location. Animal waste has slightly lower concentrations, and often we also expect to find an increase of the concentrations from the upstream sample to the downstream sample. As we see here is an increase from 1 log unit or 10 to 100 colony forming units per 100 milliliter. If we look at the right-hand graph, we see the ESBL EC over E. coli ratio. So if we start with the human waste sample, the ratio is about 10. That means 10 per 100 E. coli, 10 of them would possess the ESBL mechanism. And we see that this is the highest ratio among all the samples, and that this ratio is nearly identical to the ratio we find downstream from the city. So in that case, it would mean that the city river is heavily impacted mainly by human wastewater, because the percentage of ESBL in human wastewater is higher than in the animal wastewater studied in this particular city. Yeah, thank you.
Thank you very much, Dr. Schmidt, for this very clear and nice presentation. So it's now my pleasure to ask Dr. René Hendriksen from the Technical University of Denmark, also a WHO collaborating center supporting this project, to present on the work package number 4 for molecular characterization. So René, the floor is yours.
Thank you, Carmen. I just want to make sure that you can hear me.
Yes, we can hear you perfectly.
Okay, good. Thank you. And Carmen, thank you for allowing me to present the objectives and tasks in work package 4 about molecular characterizations. Next slide, please. So basically, all of the work are centered around a whole genome sequencing and bioinformatic workflow. So basically, the aim is to collect, as we have heard previously, isolates from bloodstream infections, colonization from healthy pregnant women provided by Olivier, also living poultry, animals of slaughter from potentially wet market presented by Jaap, and then lastly, human animal wastewater, rivers, maybe tap water presented by Heike. So from these 3 reservoirs, we would collect isolates as being explained. And these isolates will be whole genome sequenced, either DTU, or we will facilitate whole genome sequencing elsewhere. One example could be that if the data are collected in a certain country where there's already existing whole genome capacity and bioinformatic analytic capacity, then it would probably be better to actually build the capacity further in that country rather than sending all of the data to DTU in Denmark. So basically, currently we have collected data from Ghana, Pakistan, and in Jordan, the work is additional ongoing. So as I mentioned, it doesn't make sense to send all the isolates to Denmark if there's a reason to whole genome sequencing on site. So in Ghana is one of those examples where the Ngucho Memorial Institute for Medical Research, being partner in a Fleming Fund project named SEC Africa, have the capacity to do whole genome sequencing. And it would be logic to have them doing the sequence analysis and bioinformatic analysis with, of course, the supervision and assistance from DTU. So basically, as mentioned, we would collect the isolates, have them whole genome sequenced, and then analyze using bioinformatic tools. And here we would utilize the bioinformatic tools developed by the Center for Genomic Epidemiology, DTU, which have a long range of different tools available for specifically identifying the species, various subtyping schemes, AMR, plasmid, virulence, and phylogeny, doing cluster analysis. So basically, there's an umbrella of bioinformatic tools that are available freely online, and they are developed in a sense that they are plug and play, that they are quite intuitive. So it doesn't require a lot of bioinformatics skills actually to operate these. These have already been utilized for the last 10 years, and we have more than 2.5 million submissions, not counting our own analysis from more than 100 countries. So quite robust tools to apply. So this would again allow us both having the usability testing results from the phenotypic testing to compare that with the genotypic data. And this would allow us to, first of all, confirm what was conducted and found with the usability testing, but it would also allow us to confirm both the species the different subtypes. It could be that since this is E. coli, that we want to have the serotype of the E. coli. It could also be we would like to have the core genome MLST, could be MLST as such, but also the AMR genes. And here, specifically for this project, it's important to know if the strain would harbor a AMC gene, or an upregulated AMC, a true ESBL, or potentially be carbapamase producers. As indicated, we would also conduct a cluster analysis applying a phylogeny. And this is really highly important to combine all of these data, trying to understand the spread of specific genes or specific emerging high-risk clones. So this is vital that we bring all of these data together and compare and supplement it with the phenotypic data already collected as well. So basically, using this approach has a number of added values. I don't think I need to explain more about the high resolution that whole genome sequencing provide. There's a million examples that have already been published about this. But again, whole genome sequencing is a high resolution methodology and is now being applied in many clinical and diagnostic labs around the world. And as I said, it actually provides a better understanding of the AMR, both in the spread in relation to just dissemination of a gene, or also in relation to outbreak of a multi-drug resistant specific clone. What I also really like with the methodology is the opportunity to easily to do reanalysis. And just allow me to give an anecdote that when the MCR gene was published conferring resistance to colistin, this was in China, we actually here at DTU more or less pressed the button to reanalyze all our archived genomes in our repository. And after 1 or 2 days, we already knew that we actually had the same MCR gene. So this is just to show the strength about the analysis and the technology around it. The other added value is, of course, the data sharing. So there is already in place mechanisms to share data across distance. The point is more about the willingness to share data. So because the data are so rich in data, there's also for some a bit of a reluctance to share data because you never know what you actually find, and that's maybe a concern that we should all think about, because without data sharing, you would not have ultimately a surveillance system based on genomics. So this is really, really important. Another issue is, of course, data storage. There is already global repositories. We have NCBI, we have ENA in Europe, we have the repository in Japan, and I hope there would be one in Africa quite soon as well. But this would actually allow us to have a place where we can actually store all the data and hopefully in an open sharing manner, so that they can be used in real time for instance, outbreak detection. And here, just thinking about what we could have done if we had a real-time sharing of data with COVID, I think that just show how powerful the technology is and how important data sharing is, open access and so forth. But this is already in place as well. Otherwise, they can, of course, also be stored privately on huge servers. That's a bit more expensive. And then, of course, the last added value that I want to mention is, of course, the direct comparison between sectors. So here we have an opportunity to use the same approach, the same methodology, which is, of course, generic, but it can be applied to different sectors. And I think this is really a unique way to work, but not only to compare between sectors, but we could actually also compare between different organizations between institutions, between local labs, regional labs, or national labs using the same approach, because this is a generic methodology compared to more conventional microbiological methodologies where you see much more variations. So again, we are in the midst of doing sequencing for Ghana, Pakistan, and hopefully quite soon also for Jordan. So we do not have any real data to share right now, but we have a similar project with the Fleming Fund supporting the fellowships in Ghana. And here one of the fellows have actually not used the tricycle protocol, but a similar one, but with more or less the same approach. And here he have collected ESBL producing E. coli from healthy people around in different areas in Ghana. So different regions, different age group, gender, occupational areas, and so on. And basically just a bit of data we have looked into so far shows that there's a lot of CTX M15, but it also seems that based on the subtyping, that all of the isolates seems to be more commensal E. coli. So probably some kind of expansion of that specific AMR gene into different commensal E. coli, with of course the chance to further be disseminated into more harmful bacteria. So I think I'll end my talk here, and back to you, Carmen. Thank you.
Thank you, Professor Hendriksen. So next, it's our pleasure to invite Dr. Afrinish Amir from the National Institute of Health in Pakistan to present a country experience in implementing the Tricycle Protocol. So Dr. Amir, the floor is yours. Thank you very much for accepting to present the experience of Pakistan in the webinar today, Dr. Amir. Thank you.
Thank you so much, Dr. Kamam. Are you able to listen to me clearly?
We can hear you very well. Please go ahead.
Thank you so much. Thanks to you, thanks to Dr. Hore, and thanks to whole team for giving us this great opportunity to engage at this international project. Can we move to the first slide, please? Yeah. So I want to brief you on this thing that Pakistan is among one of the few countries who have been selected for the pilot program. And the journey is long. It started in February 2017. And there was a communication through the Emro region to the Ministry of Pakistan. And it was about for the concurrence for this tricycle project. And it was followed by there was a visit from the Emro region, and they have visited Pakistan, and they have selected our country based upon the visit to the different hospitals and different laboratories, and to assess the capacity of the laboratories. And finally, there was a formal letter from the HQ, and they have selected Pakistan for conducting that pilot program within the country. And Pakistan was the first country among the Emro region, and it is among one of the 6 countries who has been selected to include in this project. It was followed by within the country initiatives. There were a concurrence with the 3 federal ministries, including the health, the food security, and the climate change, as it was like a tricycle project with the One Health approach. So we have to include all the ministries and get their concurrence for the project. It was followed by formal formation of a core group and identification of the sites where the project will be conducted. National Institute of Health Islamabad, National Veterinary Lab, Environmental Protection Agency, along with the ministries, and of course, the WHO country office in the Pakistan, they have formulated a core group. Then there's a formulation of then there was formal orientation of the focal points. So it was a long stepwise activity within the country that helped us to achieve this whole big process. In September 2017, there was an identification and training of the national teams. And there was international training, and they were taught about what is the SOPs and what is the IT support that is required, and what will be the protocol for the project. Next slide, please. It was followed by the whole actual working within the labs. What is the things that are required in the lab, the provision of the supplies, the provision of the control strains. We are thankful for the organizations for supporting us in the supplies and the control strains. And it was there was a formal briefing to the whole ministries at what has been done and what are we supposed to move forward. In February to March 2018, there was a huge, that was a very toughest time when everything was in plan, and now we are supposed to do actual planning and coordination with the sites on which we are supposed to do the activities. We have initiated the formal MOUs with the hospitals, with the microbiology departments, with the obstetric departments, and then we have to get some ethical approvals for conducting the protocols. Next slide, please. So the site selection for each of the work package is again a huge task. It was like the visit from the HQ, from the headquarters, and along with the core group meetings, it was identified to go for the sites which are producing the quality data, the laboratories which are able to help us in generating the quality data, and the hospitals in which we have a maximum number of community presentation. So for the work package 1, hospital selection was done to match the catchment population, and the laboratories were selected based upon their quality testing, and the access and the logistics issues were figured out. For the work package 2, again, there was a selection for the live bird market for the poultry retailers, and initially it was the region of Islamabad Capital Territory that was selected. And there was a meeting again with the human health and the animal health and the environment health. And we visited the different sites all together to identify which were the best sites to conduct the study. Next slide, please. Yeah, during this whole process, it was not only getting the whole protocol and working at one end, establishing the networks, getting the concurrence with the ministries, with the sites, and with the different hospital and the laboratories. The main task to the whole of the, you can say, the focal point for the work packages, to develop the SOPs, to develop the protocols that can be given to the hospital or to the laboratories to conduct that process in a very smooth way. So it was a huge process. We have developed the SOPs for each of the work package, and these SOPs were reviewed by the core group, and they were then disseminated to the sites. The supplies were given to the sites. Yes, the most important thing is the data handling and the analysis. For the data handling and analysis, the WhoNet was a platform that was suggested by everyone, and it was something like a very user-friendly tool that we were already using for the AMR surveillance within the country. We are doing the AMR surveillance on you can say 20 different sentinel sites. So all the sites and all the laboratories and many people in the country, they are trained on this WhoNet software. So we have utilized this software, and we have trained our laboratory personnel and also the persons who are handling the data about this software, how to enter the data and how to analyze the data. So the formal implementations commenced in February 2018. So it took us like a whole 1 year from the beginning to the formal commencement of the plan. Next slide, please. So as I've mentioned, the training and the capacity building was the core element that was required. This project was not new if we consider one sector at one time, but it was like a combined project in which we are supposed to take the 3 areas all together. So the trainings of the 3 sectors all together on the protocols and on the WhoNet, and also on the different external quality assurance steps. And that needs to be conducted, and it was conducted smoothly during this 2018 time. Again, there is external quality assurance was a huge issue. So it was decided by the core team that we can conduct an inter-lab quality assurance, and the 3 sectors, the labs, they started to share the samples with each other to identify if they are processing the samples in the right way. Storage of the isolates, it was discussed. Due to the shortage of the supplies, you can say the refrigerators, some of the samples, they were stored at NIH, and the majority, they were still stored at NVL. For the work package 4, yeah, this was mentioned by Dr. Rene in his presentation, that few of the samples from the Pakistan, they have been shifted to Technical University of Denmark for the sequencing to find the correlations. Next slide, please. So monitoring and technical oversight has been the key, a key area, and it's hats off to the country office WHO in Pakistan. They have been doing great work in this coordination and monitoring. It's a different project, like engaging the 3 sectors all together at one time and getting the reviews and handling the issues. So it was a very informal WhatsApp group was created to have a very quick coordination between the groups. Again, it was the steering committee, multi-sectoral steering committee meeting, which held in August 2018, and it has a representation at the national ministerial and the provincial ministries. So that in that meeting, we have presented our ESBL tricycle project, and it was a huge applaud from all the sectors, and they appreciated the work that we are doing towards the AMR. Many thanks to Dr. Hore, Dr. Haiki. They have been supporting and they were guiding at each and every step. There were many WebEx reviews and meetings and external review missions as well. Next slide, please. So very briefly, it was just a very brief description what has been achieved in work package 1 in the pilot year 2018 to 2019. What we have seen is that is 1% positivity ESBL E. coli from the blood cultures and 12% from the rectal samples. In the work package 2, we have seen a huge prevalence. It is for 59.4% positive ESBL E. coli from the poultry sites. And from the work package 3, there is a different rate. And from the downstream, it was 66.6%. And from the human communal waste, it was 50%. And to slaughterhouses, we have seen a huge, the highest rate. Parallelly, for the PCR, we have, for the few of the isolates, we have the capacity to conduct the molecular testing for a few of the resistant genes for which we have the primers. And we were able to identify few of the resistance in few of the isolates. Next slide, please. So overall, the country experience. That's a unique learning experience for the country. We have started our work in the AMR surveillance since 2016. And this entry into this tricycle project helped us to look at the AMR surveillance from a different perspective. We were able to enhance the coordination between the different sectors. This was much needed, and this was the requirement in the National Action Plan on AMR in the country as well, to have the maximum collaboration and coordination between the sectors. So this project is one key project that helped us to collaborate between the different sectors. Again, advocacy on One Health, this project has helped us to raise our voice and bring all the sectors together to work on this one big area. Advanced and meticulous planning and minimize implementation delays. Yeah, I must say, this was the thing I think you have already seen. This is a 1 year whole journey. There were multiple agreements and templates and approvals and meetings and reviews. And this is, I think, the much needed activity that is required to accomplish a project in a very, very achievable manner. So that is planning is everything, I guess, and planning and a very good team that is required. Public sector microbiology lab and data management capacity. Yes, with this project, we were able to build the capacity of our laboratory staff. We were able to train them on the WHONet, and we were able to provide them with some supplies. Next slide, please. So this is one happy good news. We have completed the pilot project, and we have moved toward the expansion of the project. I work from the human side. So I'm going to explain, I can easily explain about the upscaling of that ESBL tricycle project from the human side. We have expanded our project in the ICT region. We have done an MOU and we have included one or more site in Islamabad region. And we have provided them with the quality control strains. And we have also done a 5 days training on the basic protocols on ESBL E. coli detection and identification within the lab. And data collection with that site is in process since October 2020. Also, we have developed a whole plan to expand to 2 provinces, that is KPK and Punjab. And this is scheduled in March in this month. We have planned to move towards provinces. And there were again number of meetings that have been conducted with the animal sector, with the environment sector, and we were able to identify the sites. And we are able to conduct this expansion, I guess, from April 2021. Again, from the yeah, exactly. There's just a little point. We have engaged in that CRE and WGS pipelines as a Triumph project. This project is also started in Pakistan. And I think thank you for those who have seen the success of the Tricycle project. And we have developed the protocols for Salmonella, Klebsiella, and Campylobacter as well. So this is all from my side. And I think this is the last slide. Huert, can we go to the next?
Yeah. Thank you very much,
Thank you so much,
Dr. Amir, for this very clear presentation on the experience of the application of the Tricycle protocol in Pakistan. It's really reassuring to see that after this initial implementation, Pakistan is taking a step forward to scale up in other parts of the country. Thank you very much for sharing this experience. Well, now it's my pleasure and honor to invite Mrs. Jessica Wallis from the Fleming Fund, the government of the United Kingdom. But before I give the floor to you, Jessica, I would like to publicly express on behalf of the WHO our deep thanks for the support that the Fleming Fund has been providing to the Tricycle protocol development and implementation. From the very start, the idea was just born. The Fleming Fund immediately decided to provide a fundamental support without which we would not be here today with sharing the experience and also publishing this first protocol. So thank you very much. And we are really very grateful for this support. So Jessica, the floor is yours. Thank you.
Thank you very much, Carmen, for that lovely introduction. Can I just check that you can hear me?
Yes, clear and loud.
Thank you. So yes, thank you very much. As Carmen said, I'm part of the UK's Department of Health and Social Care, and we've been working with the WHO from the very beginning. And I'd really like to take this opportunity to congratulate the team on the launch of the protocol today and say thank you to everyone who has worked so hard to get us to this point. I'm really delighted to be here. I think the protocol is a hugely useful and welcome tool for countries to use in their implementation of surveillance systems of antimicrobial resistance. And as Carmen explained, we in the Fleming Fund have supported this from the very start, from its development and its rollout in Indonesia, India, Nepal, Ghana, Jordan and Pakistan. And we've been very pleased with the results that we've seen already, some of which have just been covered. Thank you very much, Dr. Amir, for that excellent presentation. And today's launch, I think, is a very important and welcome milestone. I think this protocol really demonstrates the way in which we try to operate in the Fleming Fund and some of our key principles. We support 22 countries across Sub-Saharan Africa and Southeast Asia and South Asia directly, and we also work very closely with the tripartite. And we focus on implementing One Health surveillance based on globally agreed standards and protocols, and sharing that data. And so this project really has all of the right elements in that. You know, it's delivered a global protocol for One Health, AMR surveillance. It's been developed through our partnership with the WHO and then pilot tested in countries. We're really seeing on the ground results and implementation. And alongside this, the Fleming Fund has started to support adoption of the protocol through our direct grants to countries, and this will continue. So we really look forward to seeing the results of this long-standing collaboration with a flow of new data into global platforms such as GLASS. I think it also really allows for creating a community of practice in the fight against AMR, demonstrated today by the amount of people who have joined us. And it highlights the areas of health system strengthening that need support and investment from donors and governments for sustainability. And as others have mentioned it and demonstrated, it really is a great example of One Health in action. It unifies the control of AMR not only in human health, but also in other key sectors, the animal health, food chain, and more recently in the environment. So whilst the One Health perspective in its kind of widest sense is complex and daunting and often difficult to see how we move from concept to implementation, I think success and achievement of the objectives of this protocol will really offer countries a proof of principle that this coordination and multidisciplinary approach is an achievable goal, and that will, I hope, pave the way for wider engagement across One Health. I'll conclude here because I know we will want to move on to Q&A and we're running out of time. But I want to just conclude with saying that I really strongly encourage countries and we as the UK really encourage the implementation and use of this protocol, and we really look forward to continuing to support the WHO in rolling it out across other countries. Thank you.
Thank you very much, Jessica, for these very encouraging words, and particularly for the reaffirmed intention of the Fleming Fund to continue to support countries, several countries already, as you mentioned, 22 countries that you are directly supporting, and encouraging them to implement this new protocol. Thank you very much, Jessica. Well, now it is my pleasure and honor to invite Professor Antoine Andremont from the Université de Paris, who will be sharing with us the perspectives for the ESBL Escherichia coli Tricycle Protocol. So, and before I just give the floor to Professor Andremont, I'd like to remind those watching this webinar that you can place your questions on the Q&A box, and we are trying to reply to the questions as they arrive. So please, Professor Andremont, the floor is yours. Thank you very much.
Thank you very much, Carmen. Can you hear me clearly?
Yes, very clear.
Okay, thank you very much. So first of all, I want to thank you and the team at WHO that has made this project possible. And after a number of years now, which is a result, and the presentation by Pakistan shows the power and the practicability of the protocol. And now we have to look at what we are going to do now and what are the challenges we have in front of us. So can I have the next slide, please? So the feasibility has been demonstrated, and due to the funding by the Fleming Fund, the protocol has been set up in several countries. And so we can appreciate costs which are involved for this kind of surveillance, which is partly active, so it costs a little bit of money. The protocol now is published, so it's a public good, and it's a very good thing. It will be possible for anybody who wants to implement it to do so. And certainly, as it has been already said, this is one of the very few examples of a truly multi-sectorial One Health project, which works currently in practice. And this is not one of the least achievements that we've seen today. However, the true success is something else, probably. Can I have the next slide, please? Well, what is the true success for ESBL Tricycle? Well, as it has been said, it's relatively easy to explain what it is. This is to provide the global community with a simple macro indicator of the dynamic dashboard, so to say, that allows to follow AMR in as many countries as possible in the human, the food chain, and the environmental sector, but also when you repeat it to evaluate progress of the control policies and to allow decision-making people and bodies to compare and evolutions of these trends and to adjust strategies. And so what are the keys for such a success? Can I have the next slide, please? Well, the key fact for success, in my opinion, is sustainability. And this is also a major obstacle because we have a highly promising tool, the Tricycle, and in front of us there is this big obstacle of sustainability, and that we want to avoid the tricycle to fall. So what should we do? Can I have the next slide, please? I think that there are two main things that we have to do to achieve sustainability. First, to raise interest among stakeholders and among, I should have put that on the slide, and among people that actually do it in the field, and to consolidate budgets. And let's see what's going on with these two things. So raising interest. Why decision makers will be interested in Tricycle? Because it will help them to make informed decisions on their programs for controlling AMR. Because it will help them to have a societal benefit of success of their control strategies. Because it will help for their political image if they are successful in the field. But we also have to raise interest, as I said, for those in the field. And because if in the field the work is not done, then there will be no result and no success. Why should people devote a lot of work to Tricycle? Well, there are many reasons besides the fact that it is their job. It's networking with other world colleagues, and it is very important to know what you do in comparison with what others do. It will be very rewarding to have results such as those that we have seen in Pakistan from their control work. And also, as it has been emphasized by Jorgi, from the core protocol, people in the field will be able to build research project on surveillance, what we call satellite project, which will fit their specific goals and increase their personal interest in the project. And I think these satellite projects are really important to raise interest among people in the field. Can I have the next slide, please? How can we think of consolidating the budget? Well, the first thing that we can think of is to make Tricycle surveillance some kind of a norm with recurrent national budget. And after all, there is a lot of surveillance which are in place in many domains with national budget, and that works. We have to develop awareness of Tricycle through various communications channels, and probably we will have to work on that. And maybe more than all, we have to raise the interest of international funding organizations over that of the Fleming Fund, which has been outstanding, but that obviously needs to be backed up by other sources, either directly from the tripartite organization or by WHO, by regional or international organization, by charitable trust, maybe by ICARS, this new organization which is devoted to implement a project in IMR in low and middle income countries, and probably many others that we just have to find. Can I have the next slide, please? So in all, very much has been achieved due to the combined effort to a great WHO team, which, as I remember, was initiated by Awa Aydara, our Senegalese colleague when she was at the WHO, by dedicated international experts, and now by people in the field. But a lot remains to be done for the full success be achieved. Thank you very much for your attention. I think I finished.
Slides.
Yeah.
Can I?
No, thank you very much, Professor Andremont, for your very nice words and suggestions on the way forward. And Dr. Jorge Mateo would like to add some comments.
Sorry. Finally, the last slides just to show you countries that piloted this protocol in Africa. Was mentioned Ghana, Madagascar, Senegal. In the Eastern Mediterranean region, you heard about this very nice experience in Pakistan, but also Jordan is implementing. The Southeast Asia has been implemented was piloted in Indonesia, India, and Nepal. And the Western Pacific Asia was implemented also in Malaysia. Countries that are going to implement during this year, in Africa, we have Cameroon, Nigeria, Zambia, and Zimbabwe. From the Eastern Mediterranean, they are getting the government approval in Iran, Morocco, and Sudan. From the Southeast Asia, Bhutan is also working to implement. And the Western Pacific Asia, Laos, PDR, is planning also to implement the tricycle. The next steps for this, we are going to translate this protocol to facilitate the use of this tricycle in the different countries. We also, because the COVID situation, we are developing online training courses to facilitate the implementation. Basically including the theoretical part, but also the practical part with some videos from the collection of the sample collection to the analysis of the sample. And then we are also now working and developing the GLASS module to include this information and facilitate the data sharing from countries, mainly for those that are participating in GLASS. So thank you very much. I will just show you that this tricycle is just putting the first pieces in this complexity of the One Health approach to contain the antimicrobial resistance. And then last, just to thanks all the colleagues from the different institutions that supported the development of this tricycle protocol. Thank you very much. Carmen, over to you.
Thank you. Well, thank you very much, colleagues. We are really approaching the end of this webinar. And there are many questions that came to us through the Q&A, and the panelists are helping in providing the answers. One by one. One repetitive question is about the availability of these slides, and we will post this webinar on both the GLASS website as well as the website that is dedicated to the revision of the global system that is now ongoing. There is one question, though, that I think is really actually two questions I think are very important. There is one question asking whether the three organizations, FAO, OIE, and WHO, will be developing guidelines for countries. Well, I cannot alone respond to this question because I also need my colleagues from both FAO and OIE. But the one thing I can assure the participants in this webinar is that we are working very, very, very closely to create, number one, the platform that Dr. Jorge Pinto from OIE presented, the TISA, the Tripartite Integrated Surveillance System on AMR platform. And this is just a beginning towards, let's say, a more collaborative approach for the tripartite activities in the field of surveillance. There is another question that I think is really a very interesting question. And the person says that in Brazil, there are large companies that produce and export chicken meat to the whole world. However, this subject to scare the companies because of the economic interests. So indeed, I understand the point that has been raised by this participant on how the information could be used, and there might be, let's say, conflicts of interest. The one thing I'd like to highlight is that it's not only for the tricycle, but for all components under GLASS, the main the main objective is really to foster each country to develop their surveillance systems, to generate data that they can use to then inform their national strategies to tackle AMR. Even if any country that may be applying this protocol does not share the data internationally, but the importance here is that the countries have tools that they can use to then gather generated data and have better informed interventions to tackle AMR. So this is the main point. But I think that as we move forward and as we understand that more and more is not, let's say, a shame game, it's about building evidence that could help all of us address this issue. And as we are really close to our end, the time here, I think that we may not have much time for other interventions. I would like then to start the concluding remarks. The first point in these concluding remarks is that some of you might ask why Escherichia coli is extended spectrum beta-lactamases Escherichia coli as indicator. And from the GLASS database, what I can tell all of you is that the very first pathogen for bloodstream infections, urinary tract infections that we are observing in the reports in GLASS is exactly Escherichia coli. And it is astonishing that about 40% of the urinary tract infections due to Escherichia coli, or 35% of the bloodstream infections due to Escherichia coli, they are about resistant Escherichia coli, resistant to third-generation cephalosporins, which is an indicator, let's say a proxy for ESBL production. So it is really a major human pathogen, and this single indicator may provide us information about what is happening across sectors regarding this type of resistance. And I think that we have to consider the launch today of this protocol. As Professor Andremont said very well, it's true that we have been working with partners, with Fleming funds, collaborating centers, countries for years now. So today is just a milestone after perhaps 4 or 5 years of work. But it's just still the start. It's really, this is an initial protocol within the GLASS framework to propose a One Health model for AMR surveillance. And it is really, we would appreciate that countries that are applying this protocol, such as Pakistan, that so generously shared their experience with us, we would really appreciate to also receive feedback from the countries so that we can further improve the One Health models for AMR surveillance. As Jorge said, the GLASS platform will also have an IT module that can receive data based on the Tricycle protocol. And the existence of this IT module is not only to gather data, but it's also a way of dialogue between the WHO and countries. And we hope that through this dialogue, we can further support countries in advancing their surveillance approaches. So with that, colleagues, please let's today celebrate. It's a starting point. It's actually the milestone of a long journey, but it's a starting point, and we need to celebrate this achievement and be cheerful and optimistic and look forward towards the next steps of this journey with all of you. Thank you so much for attending this webinar. Thank you so much for your continuous support. With best regards and congratulations, Jorge and the whole team who produced this fantastic work. Thank you. Jorge?
Thank you very much. And thank you, Carmen. Just to finalize, thank you, Morgan, and the panelists that has been also answering the question. And also thank you, Carmen, for the support on this. And as Carmen mentioned, it's just the starting point. Also, Jap mentioned, please don't try to change anything in the protocol, but what we would like to know is the satellite work, because that will also provide us more information how we are going to improve or expand this Tricycle protocol in the future. So thank you very much. And again, we are going to have available this webinar and also the slides. I know that many of you have asked about this, so we are going to share with you. Thank you very much.